Right, so this week our main concern is linked lists. Now I'm going to talk about the linked list first, just to give you the general idea, just to make sure everybody knows what's going on, right? So that when you are doing the readings, things will be easier. And then we'll backtrack and talk more about some behaviors of Java. So there are some things about Java that we would like to clear out. Just as last week, hopefully we've solved your private protected issues. Hopefully we've solved it. If it appears anytime again in any future exam, we've solved it. So usually we talk about some idea, and then we also look at some things that are specific to Java, right? So today's big idea is the linked list. So what I'll do by start is show you a list of things. So for example, in this, you have a list of items, and everybody has a pointer. So 8 points to 4, points to 13, points to 2, right? And what it means is, if I am able to organize my information in this way, right, usually we call this a linked list, because there's a list of things, but there are links between them. So it's just the same way that we normally we will think about something. So let's pick an example where something follows a linked list. Let's say you are investigating a crime, right? Every time you go to one scene, it may lead you to another place. You go there, they say, oh, here's someone's phone number. This guy was here. So you go to him. Then you go there, you say, oh, but I called this person. And then you go to him. Then you go to him and you talk to him, he says, oh, go somewhere else. So the idea of linked list is something that we already have in our daily lives. We don't really call it linked list, but human beings operate with linked lists, right? For example, if you are traveling, you think of, okay, if I get to Accra, then I have to find out where does Accra lead to. From Accra, you get to the next place. Maybe Tema. From Tema, you can get to the next place. But usually, the only thing with linked list is one thing points to, so this is the simplest form. The simplest form is one thing points to something else, right? So as you are in the class right now, if I wanted to make a linked list of the people in the class and track everybody, I'll just have you say, okay, the first person, point to someone, and you point. Let you to point to someone. And if we go through that process, eventually, we'll have a linked list of people. Right. So as an example, I'd like everyone to just extend just point to someone. Just point to someone. But when you point to that person, then that person has to point to someone else, and that person has to. But okay, so let's start with her. So you point to someone. And then when you point to someone, you keep pointing and pointing and pointing. Okay. And then she also has to point. Okay. Okay, keep going. Okay. Pointed to me? Okay, who has even pointed to you? Okay. Alright, so we got almost everybody. I think I see some people left. Okay. Those who have not been pointed to, please just raise your hand so that they can complete the pointing process. Okay, so when you are pointed to, then you can put your hand down when you point to someone else. So who is it? Who's 10? Okay, so it's been pointed. So we've now got everybody. So we realize that this linked list, we could have had people in an array where we say everyone has to be at 0, 1, 2, 3, 4. But with the linked list idea, the point is everybody, that's every node, just knows what the next person to go to. Right? So if I started off with the first person, she would know who she or he's pointing to. In this case, she. But in general, it will be whoever the person is pointing to. So everybody in the list has a pointer to the next person. And that is the idea with the linked list. So realize that it actually is behaving a little bit like an array, because in an array as well, you have we're able to go through from beginning to end, except I use 0, 1, 2, 3, and they are arranged for you. But the idea of linked list, now when you are going through you have to follow the pointers. So when you pick somebody and you want to go to the next person, You just can't say, oh, I want to go to the number 3. So to go to number 3, I just can't, let me see. So to go to number 3, I just can't say, okay, I know this is 0, 1, 2, and 3. I'll just pick 3. You can't do that. With a linked list, what you have to do is, starting from 1, you have to start what? From 1 position, following the links along, right? Until you get to what? The 3rd item. So that's really the difference between linked lists and the array types. With the array types, usually, but even with the array, someone could inside, now that you've done Java, you know that the person could have implemented something inside and you don't know what it is. It's like a black box. So someone can say 0 item. From the 0 item, it just means whoever is at the top. The 1st item, that means from the 1st, I follow what? 1 link. Who is the 2nd item? I have to follow what? 2 links. Who is the 3rd item? I have to follow 3 links from what? The 1st person. So this idea is what we term the linked list. So is there any question about how the linked lists we can traverse from one end to the other?
What's that?
So for a linked list, usually we need to know who the header is. So in this case, she is the header. Right. So anytime we are looking for information, we need to know who is leading the group. Right. So that's all the linked list really needs to have. He needs to first have that header. From that point, I can answer all your questions. Right. I should be able to tell, for example, who is the 2nd item, who is the 3rd item, just by starting from the header and counting along. So if I wanted to find out who is the 4th person, so starting from, you keep pointing the same way. I hope you remember who you pointed to. So she's the 1st, you are the 2nd, and then, okay, so who is the 4th? So she's the 4th. I just follow along the pointers. So that's the idea of the linked list. What if I wanted to count all the things that were, or all the people in the class? I have to follow the pointer. Anytime I follow, I count. 1, 2, 3. And that means once I go through, we will be able to have counted everybody. But that assumes that you don't do things like pointing in the wrong way. If you point in the wrong direction, so if someone mistakenly does this, right, then that means that you could end up in a loop because you go there and then you are pointed back inside and keep moving up and down.
Can you move from the tail graph?
Okay, so in that case, they call it a doubly linked list. That means that, so this is the first type of linked list. In the first type, everybody just has a pointer to the next. But he's right, you can come up with better things. Because the problem with this is, what if there are 100 items and you wanted the 99th item? You'll be annoying to have to go 0, 1, 2, 3, keep pointing. So what some people will do is, they will have 2 links. One to the previous and then 1 to the next. That way you can go up and down in the linked list. You won't just be one direction. As it is now, you are only stuck with the one direction. Okay.
And the layouts to use very similar to the directed graph.
Yes. So I would think of it as it's a special case of directed graph, except that you are supposed to point to only one item. Right. With graphs, what tends to happen, if you have a tree, usually you think that, okay, let me see if this would, okay, it did work. All right. And, okay, so if usually you have a graph, people would think that, okay, you would then be able to arbitrarily so this is a tree. For a tree, everybody points to something, right? And you are not, it's just that for the tree, it has to be flowing in one direction. In a tree, we don't expect that someone should be able to do something like this. This is no more a tree. It then becomes a graph, right? And so if we are doing linked lists, the only thing that we ask is you are only allowed, to point to, so this is the simplest form. You only point to one other person, right? So this is a simple linked list. There's a doubly linked list where you are allowed to point to your previous. So everybody will be allowed to point to the previous. And as I said, if I'm looking for somebody, it just means that I have to start from the head. Usually there's a head and then traverse, going through, following the node. Right. If I have capability to do both head and forward and backwards, then that means that if I'm at a position, I could decide to search to my right. For example, if I were here and I know that I am the, okay, so the 0, 1, 2, I'm the second person. If I were supposed to search for the first, that means I will follow one. That means that knowing that first is lower than me, I would follow the previous. But if I know that I'm searching for someone who is higher than I am, then what? I'll follow the next. Right. So these are just ways that we will use to organize our information. So I just will ask, is everyone okay with the idea of linked list? So this is the idea before we start looking at code.
Can you please repeat its use in the modern day world?
Okay, so there are many benefits for linked lists. For example, in your operating system, when it's keeping the files, one way is it has to remember. So if you realize that you're typing, when you start typing in a file, you realize that the size of the file keeps growing as you save, hit save, keeps growing, hit save. So what most operating systems will do is it will take your file and then we'll make a linked list, right? And that means that anytime you add a new portion to the file, it'll just say, the first half connect to, make an arrow. So if you had, let's say, a Word file, so let me write that again. Let's say you started writing a nice essay, you were writing. So what the operating system will do is it will say, okay, this is one part of it. If you keep writing more, you say, okay, here's another. He makes an arrow and points to another part. Then you keep writing. And then what? You fill it up. If you fill it up, you make another arrow, right? So it means that it can keep information, especially information which it's not sure about the total size, but it knows that it will keep growing. So what you'll do is you'll make a linked list of them. So every time you add more to it, you guess what? Make one more link and join it, right? Now, so this is just an aside. So sometimes what people do is they would delete a file on our operating system. And so that means that someone will go in and maybe the file name, the person has deleted it. So once they delete it, we would expect that because the head is gone, we are not able to what? Retrieve the file. That's what usually deletion does. Just remove part of it. And it's okay, that means that chain is gone. But I'm sure you've heard about, people talk about data recovery. Data recovery, they go to your hard drive, and the thing you thought you deleted, someone can go and pull parts of it out. So because the file is being stored in chunks, in pieces, not just one block, it's a link of blocks that represents your file. That means that it is possible in some cases for someone who would write a program that will read the raw hard drive data and then try and figure out where are the other things that were pointing to other things. So just go through. So it means even if I don't know the head, yes, I open my computer, it says that what? I don't have any files. But they are there. Somewhere they are what? They are there. Unless you would write everything with zeros. So if you hear about maybe secure delete, I don't know if people have heard of that, secure delete of hard drive. That means that if it takes the information, to make sure that nobody can access it, you actually go and what? Write junk over it. So that even if someone deletes the head, there are no other pieces on the hard drive. So this is an example of linked list. Linked list is also used in some databases. That means if I have records of students and so on, I could store them, or the database would store them in a linked list. That means that student 1 connects to student 2, or even first group of students connects to another group of students, connects to another group. And that means that when you are printing all the students, you have to what? Loop through all the things in the linked list to get your result.
Okay, so this sort of an aside. If we have a file, which is, let's say, 1 gig, and then you delete that file, you notice that your computer's memory or the space increases by 1 gig. Now, if that file is still somewhere, then where did you get the 1 gig?
Okay, so what the computer is doing is it's doing accounting. For example, as we are in this class, suppose you told me that you've dropped the class. God forbid that you dropped the class. Right. That means that even though, okay, I'll just start and say, okay, 99 subtract 1. That means statistically, I am counting that what? 1 is gone. So computers do play this game with us, where they would give us an approximate, and it's true. That means that when someone comes in to take a seat, I'll say, oh, this place, the person is not supposed to be here. Then what? That time I would erase your information and allow the person to take your seat. Right. So there is a balance between spending time going through trying to erase everything every time someone says erase, and also just realizing that, oh, I can just mark you as, okay, I need to, you are no more here, you are no more here. So I'll keep all the statistics. So he'll tell you, oh yes, I have maybe 100 gig of space. But that space, there could be things that are on the hard drive that you don't see. right? The only thing is for your file explorer, like Windows Explorer or Finder or whatever, what it does is the operating system keeps watch of the files and where they are pointing to, right? So that means that the OS, it went away. The operating system would keep what? A directory, and usually it would be C directory or the root or something, and say, okay, I know that there's a file called maybe t.txt, and that file currently points here. You say, okay, you wanted to make another file, maybe it is your MP3, and you say, okay, that one also points. If you delete it, it just means that he's going to go off and what? Clear that. But he's still able to manage your files because he keeps track of the things that are what? Positive. He knows that they are there. The rest, when you need it, right, if you really need them, maybe you can go and clean the space. So he's just playing accounting. So when you delete immediately, or even if you format your hard drive, sometimes you can format until hard drive is formatted. But there are tools that someone can take and then what? Recover the information quite trivially. It just means that he just has to find out what are the things on there and rebuild the list pointing to that. Right? So that's how the linked list really is behaving. Right?
Could you say the linked list deals with the nodes irrespective of the content?
So it depends on the type of linked list. Right? Now that we've done generics, you realize that it's possible to make a class or something where something is a template. And that means that the things that are going into the template will vary. Right? So at this point, I hope that people realize that you can make any collection that contains more than one item. Right? Or something that inherits from a whole group, maybe from the number class. So numbers could be a double, it could be an integer, or something that comes from string, or something, even if you said something that comes from. You can even make a linked list of linked lists. I know that's crazy, but you could think of it that way. Okay, I want to make a linked list of all the courses. And within the courses, I want to have what? A linked list of students. And within the students, I want to have maybe a linked list of the courses they have taken. So you could make lists within lists, within lists, within. So you can go as crazy as you want. Though I hope that if you go that crazy, you keep track of what you are doing. Right? Okay. So let us now look at some of the code. So if people are okay with the idea of linked lists, everyone is fine with it. Right? Okay, so today we'll focus on a singly linked list. But the idea of a doubly linked list is anytime you have something, right? So this is my head. If I add a new item, then I also have a pointer that goes forwards and backwards. One going for the next, and one going for the previous. And that means that if I add something else, he also will have to be what? Updated with next. And then he will have to update it with previous. Right. And what that means is, if in a linked list, for example, let's say I wanted to delete this, what's going to happen to the pointers? What do I have to do to keep this list working? I have to what? Update the next. If I remove someone from a position, right? So for example, if I were going to move her from this position, that means that what? Her pointer to you will have to be updated. Right. So that means once I move, anytime you move somebody, and this is probably the most dangerous part of coding linked lists, that anytime you move someone around, you must what? Update their information. I hope people understand. So if, for example, you decided you're not going to take data structures and you wanted to go and take computer security, that means that all the things that pointed to you about data structures, we have to what? Remove them. And all the things that are now about security, we bring them in. So with the linked list, things must be kept consistent. So if there's a list of things, so just a sec, like 0, so you point to this, you point to, and you point to, and it keeps going, And then I say, okay, let us remove this one. It's supposed to be green. Let's remove this one. What has to happen? I have to what? Update that pointer. We must keep that rule so that what? We can still go through from the beginning to the end. If it was a doubly linked list, then it means I have to watch the end and also watch the way back. Someone had a question.
I also know this is the weirdest using variables. Like maybe you have
The previous and the next.
trust.
Mm-hmm.
Maybe you delete sort of.
Yeah, so you realize that linked list looks a lot like array, right? In that it has a counter going. So it means that it's possible for a developer or someone who makes the code to sometimes use a linked list. Now, the linked list is very nice if you be what? You could be moving things. Because, for example, if someone said, so you're right, the music player, we can use an array, we can use a linked list, we can use an array list, we can use even a set, we can use anything that keeps information. But the main advantage of a linked list is if I had things, so for example, if I have 2, 3, 4, 5, 6, 7, and they are all linked, right? Now, if I wanted to swap this one and this one, I won't have to copy data, right? Because the idea for linked list was what? Just point to something. So that's, the main advantage of having a linked list over some array type, in that in the linked list, whenever you are manipulating, you just what? You play with the pointers. And the pointers is very small data, it's just an address to somebody. You don't have to copy all the information. All you need to do is, if I want to swap the two things, it just means that I know that now, from here, I am not going to get here anymore. I want to now what? Come here, right? And then this one will also go here. And that means I'll remove this. And then since he's supposed to take this one's place, that means he now points, here. So I'll be removing this. And this one points here. So with the linked list, what I've done with this is I've swapped the position of A and B. The green was the previous path. First, I would go 1, 2, I'll go to A, there was an arrow there, green. Go to, so this is 4, go to B, go to 6, go to 7. Right, so if I wanted to swap two things, it's just a matter of what? Rearranging their pointers. That means that from 2, I'm just going to change his next pointer to what? To the B. And B's next will go to what? To 4. It means that, in other words, I've moved A and put B there. But to make sure that when it gets to A, he can also function. So 4 has to be told, okay, you know what? You have swapped position, and that means 4 can go to A, and then A's pointer should now what? Go to 6. So the whole idea with linked list, so that's something you have to keep in mind, is you must try and keep it as much as possible consistent. That means that if someone is there, you expect that it's within a list. And so if you move things around, you must what? Update the pointers. If you don't update the pointers, your linked list will crash, especially when it's running. Because you try and access something, and either you'll be in an infinite loop, or there'll be no one there, and then what? You crash. It's just like building, I don't know if people, there are all these Lego type games where you have to like link things from one to the other, to the other, to the other. And it has to be consistent. So if you don't follow the links, so if you make a change, it means that what? You must follow the links. If I delete this one, for example, that means that if I had a header, so let me do this. If I had a header, oh, come on. I'm moving too fast. Please be good to me. Okay. If I had a header that was previously this, and I decide to delete my header, that means that I must move my header here, so that when someone comes asking who is the head, I can update. Right? If, for example, I deleted this one, right, that means that I shouldn't still keep a pointer here. I should what? Clear out that pointer, fill it with null, so that when the person gets there, he knows that what? There's nobody following after you. So anytime you have a linked list, the main difficulty with linked list is keeping track of what? The previous and the next, watching your pointers. Right. So,
I would like to know what are the main advantages of using these versus using, let's say, an array or using an array.
Okay, so usually what happens is for arrays, right? But my warning to you is, when people thought of arrays, the first version of array, people would have thought that, okay, when I declare an array, I would have placeholders for the objects. So often I'll be copying the objects into the position 0. Like if I have an integer array list, that means I actually have the real data at position 0, next data at position 1, position 2, position 3, and so on. Right? So that one was nice. But the main problem with that is, initially, people in memory, usually the computer will try and keep the array in a block altogether, right? But it's not very efficient if you are moving things around, because that means you're going to have to copy things from one location to another and so on, right? So what currently is happening is, so things like array list. So array list is blending the array with the list. So he's saying, I'm going to be an array, but inside. So that means he gives you the thing like square bracket, 0, and so on. He gives you all the features of an array. But inside, he actually keeps a list, right? Now, if you take the normal list that Java has, he will just say, well, I'm not really going to do all the array indexing features, but I do have all the things. I would say, get me the next person, add something, remove something. So he has all of that. So what I usually do is, if I know that I have a structure where things can be moved around a lot, maybe insert someone in position 2, put someone at the end, push someone at this, then I would I would go with a list or an array list, because I know that the data structure that is kept for that one, it just uses pointers, right? For the array one, usually the issue is you have to worry about whether it's actually copying information from one location to the other. So for example, if you say move from position 1 to 3, is it going to say, let me go and copy what is here, put it here? Or is it just changing links, right? So that is the main argument why the link lists became popular, right? So currently, they are, I think, one of the most useful ways. But the only difficulty is you have to track your pointers. With array, it wasn't about pointers. It was just, okay, they are all arranged in a block. So you pick the first person, second person, you know that they are all there. But with this one, an array, you realize that when you declare an array, I don't know if you realize, you have to specify the size. So he knows how this one I'm dealing with. Array of 10. If you wanted to make a new bigger array, what did you have to do? Make a new array, copy all the things. That's a lot of work. Right? Array list, that means that now they're realizing, oh, you know what, we can borrow some things from the list feature. In that we can have arrays, but we can link them. So you can actually have one array connected to with a pointer like a linked list, to another array connected to another array connected to. So you can actually do that. Right? Or you can just have a full, everybody is a node pointing to someone else. Right? But the advantages of those are, whenever you are making a new, whether you are reducing, increasing, you don't have to redeclare a whole block of space and then copy things in there. Because array, that was the problem. Anytime you wanted to add a new thing, if it's 10 and you're going to 11, you have to redo the whole thing. But array list is more dynamic. You can say, okay, I have an array, but I can link them together. And a list would be, okay, you know what, I'm not even dealing with this array business. I'm just connecting nodes. So it makes it easy to add and remove things. Okay, so last question, or if there are no questions, I'll move to the coding part, implementation. So everyone is cool. You are sure everyone is cool? Okay. So since everyone is sure, let us start going through what Java has for us as far as your question. Okay, so when you are tracing the items in a linked list, right? What has happened is often, I think in computer science and a lot of programming, we tend to say the 0th item. So there are some languages, so Java is one of them, where we tend to count from 0. So 0 is the first, 1 is the second, and so on. But there are some other languages, I think Visual Basic, where depending on the version, they count from 1. So by convention, in this class, since it's Java, when someone says first item, you go and bring the 0th item. When someone says second item, it means the item at position 1, just because of how Java behaves. Right? Okay. So what we'll be looking at is how Java actually places the linked list. But before that, we'll just review collections. Right? So this is a diagram. This is not. Let me see. Right. So this is a diagram that represents some of the inheritance and how how the different classes are related in Java. So you have an abstract collection and abstract lists, subclasses that, and then array lists, vector, abstract sequence lists come from that. And the linked list is coming from the abstract sequence list. And the vector, so you realize that everybody adds more restrictions when they are doing a subclass. So a vector is almost like a matrix, but you say, okay, here is a list of things, right? But there's a direction to it. But a stack would then say, okay, you know what, I have list of things, but there's a rule about how you add to it, because now you can't just add anywhere. I want you to add from the top and remove from the top. So everybody has a specific extra behavior that they add when they inherit from somebody. So linked list is here. So you can see that linked list is getting some things from collection. Right? So a linked list is actually falling into the collection group. It has some properties. So let us look at, so these are the abstracts. Right? And these are the various interfaces. And you realize that the interfaces are all using what? Generics. That makes it possible for Java, hopefully, I mean, one of the draws of Java when it came was, oh, they have, if you are doing something, say, oh, they have array list. Like, oh, wow, is that so? Then that means you don't have to write your own array list. You can go and use this. But here, oh, Java has string now. Wow, they have string. Because in the olden times, you had to do your own car thing and move around. So having this and making it also a template makes it very attractive for developers. I'm not selling for Java. If you like another programming language, you can move there. Right? But I'm just telling you what some of the benefits are. And these benefits, other programming languages have similar constructs. So if you go to C, C#, J#, F#, wherever sharp you are going to, right, you will find something that is like this. So if I teach you this, don't just say, oh, I only learned it in Java. If you go to another, I don't know, if you go and work for somebody, work for yourself, start a company, build a code, these things are things that what you can ask about and bring the knowledge you've learned in this class into that, right? So you're seeing here as well. So there's collections, list, queue, and set. So a set is an ordered queue. There's an order to it. Linked list is there. There is the queue sorted. So these are all interfaces. And an interface has a set of methods. So if you look at the linked list, he is getting from queue and going up to collection. He has iTravel. Do you remember what the iTravel is? Have you used the iTravel yet? Oh, wow, really? Huh, okay. Nobody has used the iterators. You've used iterators. You've not used iterators. Okay, so that means I have to discuss iterators. So we'll do an example with iterator. Okay, so let's do this. File new. Okay, so this is just a simple main, and what I'm going to do here is I'm going to add in people like array list, so I'll just use array list. Why is he complaining? Supposed to, right? And then usually in a list, I can do something like dot. Come on, fast. Yeah, my computer freezes sometimes. Okay, so one, my lists dot add. I can add 2. I can do my list dot add. I can add 3 to it. Right. Now, if I wanted to loop through my list, there are many ways that I can do this, right? One way is I can say for int I equals 0, I less than my list. You have to watch those. One of them is size, one of them is length, right? I plus plus, and I can do system print line. I would say I is equal to, and then I'll pick my list gets. So this is one way. Right? I think everyone is okay with this approach, right? So that means that I can define an array list, add things to it, and make a for loop where I'm saying I, and I'll keep calling get. So get 0, get 1, get 2. But this is dynamic because I'm having what my list.size. So I'm counting from I to my list.size. And why is it still complaining? Well, there's no. So if we run this, come on, be good. Or he's not, okay. Oh yeah, just run it anyway. Okay, so 0, 1, 2. Right, so this is one way using this type of approach. Right. Another thing I could do is I could say my list. If everyone is cool with this, right? Everyone can do this. Okay, cool. For string, my item. This is another one. This is very okay. Maybe people don't do it this way, but this is another possibility for you. Right. So Java has two types of for loops. One loop, that's the int I. Okay, there are many loops. There's while loop, do while. There are so many loops you can do. But I'm just keeping with the for, because this for loop you can rewrite it as a while loop, right? Do while, do until. You can play with it. It's just about moving the I equals 0, the counter increment into different positions. But this is slightly new. This one looks a lot like what there are some languages which do this. I think PHP has this, Python has this. I think everyone has this now. This type of iterator. So the idea with this was to say, I have something. So he says string because he knows that these things are strings, right? He's saying that this syntax just means so. I have a list to go through. So my list or whatever collection you want to go through is in the colon right hand side, right? And it's saying that every time you get something from this one, put it in what? My item for me. So that means if I wanted to print something in here, it's actually going to be my item. Now, because I want to do my own counter, right? I am going to do j equals, so that will be the first time, so that I just wanted to print about the same. So I'll make this j, and then I'll do j++. Just so that I can be able to what? Count 0, 1, 2. But this is another type of loop. Right? All this is saying is, for any of these things in the collection, my list, every one of them, assign it to my item, and let me run through. And then when it runs through, we'll go and pick the next item in my list, put it in my item, and I can use it. And it means that when it doesn't find anything else in there, it will then what? It will stop. This is the same code. It just means that this would have looked like this. It would have looked like string my item is equal to my lists dot get. So how people see the change I've made. It's just to say, anytime I have something, go and get that item from it and come and assign it to a variable. That's what this loop is doing. This type of for loop. So it says, I want to go through a list of items. And this actually works for many of the collections, right? And the reason why it works is the collections have what we call an iterator, where you can say, what is the next value? So that's all the Java is doing. Every time he just asks whoever is here. So he asks this person, what is the next value? Then the class should return it. And then he assigns it in here. Then he asks, oh, what is the next value? When he brings, he assigns it in. So that I don't have to worry about this I0++, all of that. Java handles it for me. Just by using this iterator idea. That is, every time I just ask you, what is the next? What is the next? What is the next? If there's no next, you just return what? Now. Right. So the last one is okay. This iterator, right? Just because it says I have to include, come on. Right. So every collection in Java, so if you remember from this diagram, every collection had what? An iterable. So it had an interface, and that iterator was supposed to call and return an iterator. An iterator is just a class which you can ask, what is the next? What is the next? And it will return to you what the next value is. Right. So I'm going to use that one in this as well. So I'll do I just want to differentiate these things. Did we run it? Okay, before I do this, let me run this code so that people can see that I'm not lying, this loop will work. Right. So let me say this is my first loop. So I'm just doing this. This is my second loop. Right. So let's just quickly run this. So that whenever I sprint, you can tell, I think that's because of my first class, the corporate thing I did. Right. So the first loop said 0, 1, 2, second loop said 0, 1, 2. So it means that these are valid ways to loop through a list. Right. Now, the last one is with this iterator. Right. And what you see with the iterator is, if, for example, let me start by saying system.out.println so what this iterator does is he has a method called hasNext. So the iterator, the most important thing is he's able to say, do you have a next value? That's the question you ask. Do you have a next value to give me? If you have a next value, then I can use what? Next. So hasNext is the Boolean. Just returns if you have something more to give me. And next is what? Based on how the iterator was defined. In this case, I defined my iterator string. So it means that whenever I say, get me something next, it will bring me what? One more string from the list. So using these two, so I'm going to use these two. So I'll say, if my iterator dot hasNext, I'm going to do it almost like this one. I'm still going to be counting. This is not J, but with my K. And I'm going to call this my third loop. Right. Now, if I know that I have a next, then what I'm going to do is, the next thing, I'm going to say string my iter item, my iter dot next. And this is my third loop. Right. So that means that I could be asking, do you have next? Do you have next? Do you have next? Right. So let's run this. I hope the code is understandable. Iterator. An iterator is... What happened? Oh, thank you. That was fast. Okay. So an iterator is something that you can ask, do you have something for me? Give me the next value. So that is the game I'm playing with them.
Are we not supposed to use a loop instead of a condition?
A loop here for this iterator. Oh yeah, it's not just if. It should be, it's better as what? While. So that he keeps going, not just once. If would have just done one time. So you ask, do you have more for me? So not just once, but keep rolling through. So let's run this. So thank you very much for the catch. Still complaining about my previous classes. Alright, so you can see the iterator, so I'm able to do it. Third says 1, 2, 3. Right. So it means that these are all properties that all the collections have. Any collection, if you want to print the items in them, you are not limited to just using this one, this for int I. Right. So my only comment about this for int I thing is, this for int I is really often, it's good at saying get I, but depending on the data structure that you are using, you may be wasting a lot of time. For example, if I have a linked list, and every time I say go and get me 10, you have to go and move through from the top. Next, count till you get to 10. And I say, oh, get me 11. And I go, starting again from the beginning. 1, 2, 3, 4, 5. But if I am using a linked list, now when I say get me next, I just have to keep track of where I am. And then what? The next item. So if you say get me next, I say, oh, I know I'm at the 10th position, move to 11. Get me the next thing. Oh, I know I'm at the 11th position, move to the 12th. So with this, the iterator, especially iterator, with linked lists, array list types, can be very good. Especially where what? The linked list is very efficient in tracking from one item to the other. Because anytime you ask him, go and get me next, and you don't tell him, go and get at item 10, because the linked list, his behavior is when you say, get at item 10, you start from the beginning, right? And start counting. 0, 1, 2, 3, 2, it gets there. But if you are able to use this iteration approach, or this, Java has this one as well. I believe that what Java will do is if you do this, he will try and pick the most efficient way to go through the collection for you. Right? So if you are unsure, you can do this. But the iterator is also going to be very efficient. Because most data structures, what they'll do is, because they know you just want the next value, within the class, they'll keep track of where they are. So that when you say get the next, he will simply what? Have a pointer that points to the next item. So even if it's a set of things, he can have them in a list. And he knows that I have pointers to them so that he can keep track of where am I, where is the next. Right? So that's why we like iterators. This is also using an iterator implicitly. Right? So they are just different syntaxes. So is everyone cool with how we are moving through the collections?
Is it like you use an iterator for a set of data that is stored in an array in which the array has maybe some codes, like some of the holders aren't having anything, they are just having a norm.
Okay, so if that is the case, so if you want to remove something, so if something was there and you wanted to remove it, why didn't you completely delete it? That's suppose you left the whole with blank data in there. I hope you understand. If I have a linked list, so this is, let me see if this will work. Right. If I have something, so let's say I just have these 4 items, and right, some of these have data in them, and this one has nothing. Right, that's what you're asking. So my question is, if you know that this has nothing, why don't you delete it and do this? What are you doing with it? That's my question.
Yeah, for the link list before, and if I change it.
Oh, but for the array.
Yeah, for the array, I was talking about the array.
Okay. All right, so for an array, there are many ways that people deal with arrays. So for example, if I have an array, and I have previously, I had 1, 2, 3, maybe 4. And I know that I want to delete this one. What most people do is, once they delete the item in the array, they would then what? Erase that and then copy over 4. That means that I will just, instead of doing this, wow, I've forgotten how to do my eraser. This is not good. But let me use another color. That means that I'm going to totally, try and do this. Wipe this out. And then go and bring 4 and put it here. And forget about this entirely. So this is a strategy that some people do with arrays. Right? That means he has an array, there are spaces. Now and then you what? You press it together, you compact it. Right? Else when you are going through the array, then you have to check. You can be looping, but you have to check, is the value blank? And then you skip it. Right? But the idea with a linked list, array list, and so on is usually when something is deleted, it's not a blank spot standing there. Because what? He plays with the pointers. You move it around him and say, okay, this place, there's nothing there. He just jump over it. Right. So I hope that is answered the question.
So how does the hasNext mechanism work? Does it work based on pointers or based on position?
So the hasNext keeps track of where he is. So that means that if I'm using the hasNext, right, that means the iterator will come and will start and say, okay, I'm currently here. So this is my current position. Oh, sorry. So if you ask me, get me the next, that means I'll bring you this. If you ask me hasNext, I'll check to see if this thing is null. Right? So get me next, I'll get you this. And then I'll then put a reference. And then I will keep track of, okay, I'm supposed to be here now. So it's just one variable where after you do the next, you move. So if I say, okay, get me next, that means I'll get you this. And then I'll now assign, there's nothing here now, so I have to what? Go here. So you just need one variable to keep track of it.
Because with the list, you see that there's pointers, right?
Mm-hmm.
So when you are from one place to another, you use the pointers to know where you're going next.
Yes.
But with an array, hasNext also work there, but from variable to variable, they don't point to one another. They are just in position.
So let's see the counter for that one. So for an array, if someone were in, so you can implement, so please don't, how do I put it? Don't think of it as, you can never maybe implement an array type that has an iterator. You can. So the only thing is, if it's an array type that has an iterator, it just means that what? I have to keep track of where I am. I have to have an integer. If it's an array like this, I just have to have an integer saying, am I at position 0, position 1, position 2, and so on. If I am using a linked list, I don't need to keep track of an integer. I need to keep track of the node where I am at. And that node, if I wanted the next, what do? The node already has a pointer to the next. So when you say hasNext in a linked list context, it just says, whichever node you asked me about last, what is the next item? because that node has a what? Has a reference to the next. If it is an array where you're keeping 0, 1, 2, then you need to keep track of what? The index. That is, maybe I'm at 0, I am at 1, I am at 2. So that is, I think, the difference between has next in the two. Right. The slides have, okay, maybe it's, usually I try and balance out the understanding in the slides, but let's go through the slides a bit, just so we can get to, we are almost out of time, right? Oh. Almost out of time, right? So what I'd like to do is, the slides will go up today, right? So the book is there, but I also put up the slides as well. And so for these slides, it's just taking you through different things that a linked list has. So the first thing is to say, oh, for a linked list, we need to have something that points to the head. And then every node, so a node is like a spot in the linked list. We need to have data and a link to the next node. This we've already talked about. It's just repeating the same thing. Right. So when you're reviewing, that's what they're saying. For every linked list, the different things in a linked list are called nodes. And then every node has data and a link to the next item. Right. And this is an example with chairs. So we play that game in class where everyone points to the next item. Right. And the item can keep increasing. So if I wanted to remove something, and we already talked about how to remove, we just have to what? Update the pointers. So this thing is not animated, so that's why I was going through the exercise of drawing the arrows. But if I were removing, so for example, if there are, in this case, there is chair 20, 4, and 10. If I removed one of the items, that just means that what? I have to update to 24, so 4 has left. So that means that I just have to keep track of the fact that, oh, there's a new starting point for me. Right. So for the linked list, the idea is just to play the game where you have to keep track of the beginning, right? And if this is removed, that means that you just have to what? Hop over it. Tell 20 to now point to 10. If 10 is removed, then just tell 4 that what? There's nobody there. If 20 is removed, the first chair, that means that tell him that you should not go and start from 20. You start from where? 4. So that's just the idea with the linked list. Right. Now, this code over here, right, is giving you a template form for what the node will look like. It's using templates to do this. And it's just saying every node has a what? So it's using template T. There's data in there, which is of type T. So if I made a node that was string, it means the data in there is what? It's a string. If I made a node that's an integer, it means the data in there is an integer. So there's a constructor, right, where it says, there's something that I want to use for my data and something that I want to point to next. So you can easily create a linked list. So that means that every time I'm making a node, I'll tell him, oh, here is your data and here is what? Your next. And by doing this, you can actually construct a linked list. That means the first item, I'll say, here's the data, here's the next. Here's the data, here's the next. So we can construct this very easily. And there are some methods there like setting data, setting next. So this value, that's why I say that if you remove things, you have to what? Set the next value. If next is not pointing to anything, then you should set to what? Now, meaning that you can check to see if it's there. There's get data and get next. Get next is returning what? That's what I was talking about. He has a reference to next. So if I have an iterator, I just need to point to one of these if I'm using a linked list. And when you say get me the next, I don't have to go to the whole linked list. I just come to what? Where I am currently and get what? The next value. Right. And this is the linked list class, which is also extending T. But he is also using that T to make an instance of, so this is very cool, make an instance of node who is also T. So it's like one template is using another template. Right. And in Java, they do this a lot. Right. So if you saw the hierarchy there, the hierarchy had one template class, extends another, extends another. Right. And what he does is he has here a private variable called head that he needs. He needs to always know where is the beginning. Right? Without knowing the beginning, he can't even go through the list. So he needs to know the beginning. But every time you add something to the list, what you say is, okay, I'm going to make a new node. Right? And when I make the new node, I'll say, okay, my new node is there. You should point to head. So he knows that, okay, as head is there, so let's see this one. So what he does is he tells you to set your next. When you are given a node, you say, oh, set your next to this person. So what he does is, anytime a new node comes in, who is added, they tell the new node, oh, you, please know that this person is ahead of you. So he knows it. And then he says, okay, you, the head, you are the new node. So he makes, every time you're adding something, so it just means in this case, the person is now coming ahead of her. Right, so this one is, okay, for the specific code, what it's doing is, if she is the current head, and then someone else is coming, it just means that that person is going to become what? The new head. But what happens to the new head is that the new head has to be told that his next is what? The old head. So there are many ways to add to it. For this specific code, all it's doing is, anytime someone is coming in, you are coming to the head. And when someone comes to the head, he just points and says, oh, that's the head. This code is a bit confusing because you see head being used twice. This first time, head was pointing to the old head. But then when he finishes, he sets it to what? The new head. So it means that the new head then becomes the king of the show. Right. Now, to see if something is within the node, so what he's doing, you say, okay, if I want to go through my list to see if something is within this linked list, I am going to first start off by saying the head should be what? The current head. So this is like the iterator issue. The head. So if I want to start, I'll say, whoever is the current head, you come. Now say, if the current head is not now, then what he says, you go and get me some data. Right? And checks to see, so this is checking to see if you contain the data. So you say, if that thing I have equals what is within my current, return true. Else, take the current and take the next of the current, but replace that. So this is just a variable here that is defined within this method. Say every time, go and reassign who you are and get the next person and put him there. So it's almost like after I finish using the current, in order to go to the next, I have to what? Go and get that value, whatever the next points to. It could be null, it could be somebody else. Go and get that item, come and replace with current. So it's almost like I'll bring her forward, ask her a question, and then I'll say, okay, I want to ask another person. So go and call the person who's after you. And then you go and call the person after. And I'll ask him a question. After I ask him a question, I'll say, oh, go and call the person who's what? After you to come and take your position. So that is an example, another example of what? The get next. It's almost like, instead of going through iterator class, here, he's doing the iteration himself. I hope people are cool with the idea. So the code is, I hope, understandable. But the only thing you have to watch out for is when you see something like head, watch the order of operations. Because in one position, head means somebody old. And in the next position, head means somebody new. So you can see that here, where head was used here. This was the old head. And the head is being replaced with a new head. You can see it also here, where current starts off being the head. But then, here you say, get me next. That means that the value of current has what? Has changed to the next person. So you keep changing. So that's the idea. Right. So for the linked list, what they are doing is have a linked list class, create a node, and inside there's data and next. Have people seen this one before? Like a class defining another class? I think, yeah, so not just the static, but the fact that there's one class which is what? Within another class. You can do this. Right? Usually this is done when you know that, okay, nobody, for the linked list, he usually doesn't give people his node, and he's not expecting that someone should be working with his node. You should ask the linked list when you want something. So in that case, he will define it as an inner class. So this is an inner class. That means that he will be able to use all of these things, and he will be able to use his things as well, because he is part of him. He's like one of the private people in it. Right? Static just means that he's going to exist forevermore. So he's saying, okay, I want to have this class that's always going to exist. It has data and next. You can make instances of it. Right? So, okay, so starting with him, he has, so this is just expanding on that code. That is the head. This is a node that represents it. When you make the constructor, the head is initially null, meaning there's no data in there. But when you add something, he'll say, I want to make a new node. But because the node is already defined in him, he can make one. So this is a programming style. If you are coding something and you don't want to go and create a whole new class file, the data there. So don't always just say, I want to put everything in one file. But the idea is if you have something where he's using things that are only for him, usually he can be what? An inner class. So in this case, the linked list is supposed to work with his node. He's not giving away his node. He's giving away what? Data. You can say, get me next, or get me data. He can get the data for you. But he's just saying this class belongs to me. And contains is also just the same code. It's just repeating. But the only difference here is we are putting the class node inside the linked list because the linked list owns it. It's going to be using it. We are not expecting someone else to what? Make an instance of node and be using it. You are allowing the linked list what? Encapsulates all the information. So he handles all his work within him. Right. So that's why that one is there. Right. So we are just saying that's an inner class. So that was what I was explaining. Just more notes on inner class. All right. So how would we count the size of a linked list? We would what? Take an item and what? Start doing has next. Right. Counting the size. You remember this method? Sorry, just point out to you because you may wonder what does counting. You see this contains method, right? If he's searching for something, so this is a dirty trick, but if you look at this, all he has to do to count the items is, he shouldn't check if something is equals. He should just be doing what? Has next. But has an integer that every time he does one has next, he increases it. He has a has next, he increases it. So this thing can actually count you the size, but you can modify it a bit. So don't go in there to search for data. Just loop through till you get to now. Because everybody, when they are created, where is the node guy? The node should have had a constructor. Like if you make a node where the next is now, right? But even the head initially was supposed to be, here it is. The head is now. So it means that if I keep going and saying has next, eventually I'll get to somebody who has what? The next as now. Because the idea was, if you are the person who is at the top, you are not pointing to, well, your next will be now. So it's possible to modify some of this to do the counting. So if any assignment comes that says get size, that is it. Get K is similar, right? Instead of searching to see if you are finding something, you are counting. And then when you get to the item, that is the same as K, you what? You stop. Are people following or are people falling asleep? There's a lot going on. Okay, let's wrap up soon. Right. This is the size one. Okay, this is the iterator. So I'll just point out. So this is just the last item. We use iterator, and then I'll stop. We use iterator. What you see is we define an iterator. So you were also asking. This is wrapping up the iterator issue. The iterator is defined as a class within the linked list. And what he's doing is, the moment he's created, he says, well, my next node is what? The head. Means that if the first time an iterator is created, if you ask him, do you have next? What does he have to say? He just has to check. Is my next node what? And now. If it's not a now, so that's what he's saying. Is my next node a now? If it's not a now, then what? I have data for you. Right. Now, if you tell me to go and get next, I'm going to play a very smart game. I'm going to say, well, I know that I'm supposed to get you some information. So I'm going to go to that node, get the data, right? I'll return that to you. But before I return it, I'm going to update that next node I'm keeping track of. Update it to the next. So that if you ask me to go again, I won't go and count from 0, 1, 2, 3, 4, 5, 6. He just has to keep a track of one variable. Next node that points to wherever he is right now. So that's how the iterator is working. And you can use this concept to do for other data structures. That means you have a list of things. Anytime I ask you to go and find, don't start from the beginning. Wherever you are, get the next. And remember that was where I am. So that when someone says, what is the next value? You do what? You go pick that item, you get the next. So that is the iterator implementation. So it says everybody, node included. If node is a subclass. If linked list is going to implement the iterator interface, then he has to return a new iterator. But the iterator, he created a class to represent the behavior. Because you can't return an iterator. You have to say exactly what your how's it going on? Now, in conclusion, so let me just, I know there isn't any. This is just inner classes. It's just for your happiness and your reading. For your reading happiness. Right. Okay. So this is the Java API. Right. And if you search for Java API online, they'll give you a web page that looks like this. And this thing, I think it's good if you start browsing around in it. Right. So what I did in the slides, there's a nice diagram. But if you go to the Java API, it says that collection has iTravel. So it actually lets you know how things are related. It says all known sub-interfaces. So all the people who are subbing of him, there is list here as well. So it means there's an interface for list. Oh, the internet has gone off. Oh, okay. All right. So please, read through the slides. On Wednesday, we'll have another small pop-quiz about LinkedIn.
Please remember to read according to what's in the course outline. Not reading side, the course outline. Read according to
the readings are on linked list, so please read through. So the problem with arrays is, for integer arrays, an integer always has a value. So whatever you do, something there. Unless you decide that, okay, I am doing only positive numbers, so I'll put it minus 1 to minus 2. Or you have maybe another variable that constructs how many things you have used. So that if 4 is there, you also remember that I've only done 3. So that will get the instruct. Right. But there are some arrays, if you make an array of, let's say, students, that one you can put a null there because students allows you to have null. So that means when something is there, someone's asking, you can skip. Yes, you can skip, you put null. But if you don't always want to, like, if I have, let's say, 100 items, and I have something at the beginning and something at the end, if I want to print, do I have to go now? So what people usually do is, when I remove something, I'll shift it, so that it's always together at the top of the array.
The thing we've done is, the to-do list assignments.
Yeah, some people didn't do it. But everyone shifts.
So there are most of us do it.
Yeah, but some people also skipping the values. But if you skip, then the problem is if there's something at the beginning and something at the end, your array will have to do everything. But if you've been shifting, the things will be at the top. And you need to be fast.
So you can use the iterator on the linked list.
You can use iterator on a linked list. All the collections, you can use iterator, set, start, everything. But the only thing is, if you use an iterator, for some of the data structures, you are not guaranteed about the order. For linked list, you know that there's an order. So yes. But if you use an iterator on like a tree, you don't really know. I mean, how do you define who is first in the tree? So he's just saying you will go through all, but he's not saying exactly how you go through. Right.
It's like you want to find, okay, suppose you have a linked list of like the numbers, like 1 to 10. I want to find all the even numbers. Because I chose that.
Yes, you can use. That means I will just be like this, but the only difference is where's my Java. That means that within here, if it were a number, the moment I get it, then I can do something like is my item even? So I can do this check, and then I'll print. If it's false, then I skip it.
So first, if you are going to get an item from the linked list, like you have to start with.
So getting an item, because everybody who comes in head places the old head and pushes him aside. When you are getting an item, he actually has to start from that head, and then we'll keep searching until we find him.
So it's not like I'm like this is the first one.
Okay.
I want to add like a new one. You shift this one.
So the implementation that is currently there is working as if this is currently the head, and I want to add an item. What it does is to make a new position, put the new data you want in there. My head previously pointed to this, but you say remove this head, point it to this, and tell this guy that is his next. That is the code that Java is using. But I have written it in different ways. It just depends on what the convention is. So in Java's case, their convention is anytime you're adding something, it adds it to the head of the linked list. But different programming languages have different behaviors. But just for yours, Java right now, that's the behavior. So if you are searching for something, you have to search from here. Go through.
Like, yeah, I fell asleep.
You fell asleep. What happened? I was boring you.
No. I stayed up late.
You stayed up late. What?
So I missed like 2 weeks.